Hello, my name is Mr. Asprey and I'm actually recording this intro after I've completed these questions. So I've made the video already. Normally I do the intro first, but I've had to come back and re-record the intro because these questions are really tricky. So I want to give you like a big warning before you do them. That they are essentially, some of them are like A-level standard questions. I've seen questions like this on A-level exams. So question 1 is straightforward, and then 2, 3, 4, 5 and 6 are all very difficult, with question 4 being, I think, just insanely tricky. So much so that I kind of wish I renumbered these topics and put this one as number 60, because I think it's actually maybe even harder than vectors. But anyway, good luck with them. Don't get too disheartened if you can't do them or if you need help. That's absolutely fine. And if you do enjoy doing them, then A-level maths is for you, because so much of A-level maths involves calculus like differentiation and then also integration as well. So good luck with this. I really hope that my explanations are helpful, and I'm going to hand back over to Mr. Asprey of about 30 minutes ago. Okay, let's get into it. So how to differentiate? Well, it's all about taking the power. In this case, the power is 3. And multiplying it by the coefficient. In this case, the coefficient is 1. So we get 3x, and then we drop the power down by 1. Okay, here the power is 2. The coefficient is minus 6. So 2 times minus 6 is minus 12. And then we drop the power down by 1. So it becomes x to the 1, which we can just write as x. And next, this is 15x to the 1. 1 times by minus 15 is minus 15. We drop the power down, x to the 0, or anything to the power 0 is 1, so we don't need to write that at all, because we're timesing by 1, it makes no difference. There we go, we've differentiated that, and that is 3x squared minus 12x minus 15. Lovely. Okay, the curve has this equation, so it's the same one as the one above, and it has 2 stationary points. Work out the coordinates of these 2 stationary points. Okay, so stationary points are when the gradient function, dy by dx, is equal to 0. So we take our gradient function, which we have already found, and we set it equal to 0. Okay, how am I going to factorise this? Well, actually I can see straight away we can divide all these terms by 3. So I can do that now because it's equal to 0. I could not have divided this by 3. Do not do that. That is the gradient function. I can only divide it by 3 now because it's equal to 0, and dividing 0 by 3 is just still 0, and I'm trying to solve the equation. Please don't try and simplify the gradient function. Okay, so this can be factorised nice and straightforward. X minus 5, x plus 1, just by doing our quadratic factorisation. And x is equal to 5, x is equal to minus 1. Okay, but that's not the end of the story, because it does say the 2 stationary points. So I do need to write the coordinates. So I need the corresponding y values. So I'm going to go to my calculator and I'm going to sub x into the actual curve. So I get 5 cubed minus 6 times 5 squared minus 15 times 5. That's going to give me the y coordinate that corresponds to x is equal to 5. Okay, now let's find the coordinate when x is minus 1. So I always like to do these in brackets when I'm subbing in a negative number to avoid making a mistake. So I do minus 1 cubed minus 6 times by, in brackets, minus 1 squared, and then minus 15, and then times by, in brackets, minus 1. Okay, and that gives me an answer of 8. Lovely. So y equals 8. So we have the coordinates, because it doesn't ask for a coordinate pair, so let's just write them out as coordinates. Voila. Beautiful. Okay, we've got a solid. It's made of a hemisphere and a cylinder, and we have the centre of the circular face of the hemisphere. Yeah, bloody. I can see the diagram. That's enough. Thank you very much. It says the volume of S is V, where V is 1/3 pi y. Find the maximum value of y. Okay. Interesting. Tricky question this, for sure. Right, we're going to start by actually finding the volume then. So the volume is a cylinder. So the formula for a cylinder is the base area, which is pi r squared, times by the height, plus a hemisphere. Now the volume for a sphere is 4/3 pi r cubed. So a hemisphere is half of that, so it's 2/3 pi r cubed. Okay, so those are the formulas. We know r is x in this, so I can write x squared, and I know h is 20 minus 4x. So that's good. And again, I know that r is x, so that's x cubed. Okay. Right. What we're going to do next is we're going to... what are we going to do? Yeah, let's expand out. So get 20 pi x squared minus 4 pi x cubed plus 2/3 pi x cubed. Okay, good. Let's now take out a factor of pi. So I have 20x squared. And then what have we got here? Minus 4x cubed and plus 2/3 x cubed. So how many x cubes is that going to give us then? So minus 4 plus 2/3 is going to give us minus 10/3 x cubed. So minus 10/3 x cubed. X cubed, sorry. Okay, and now it asks us to take out a third as well. So I can take out a third, and that will just make everything inside the bracket 3 times bigger. So that becomes 60x squared, and that becomes 10x cubed. Okay, great. Okay, so now we've got y. Because remember, the volume is equal to a third pi, which we've taken out, and then multiplied by y, which is obviously what's left over. Okay, so I can write now my expression in terms of y, because y is in fact what we need to maximize. Lovely. So how do we maximize something? Well, we use differentiation. We differentiate it, and then we set it equal to 0, because that's where the maximum and minimums are when the gradient, or the derivative, dy by dx, is equal to 0. 2 comes down, times by the 60 makes 120, drop the power down to 1. 3 comes down, times by the minus 10 to make minus 30, drop the power down, becomes 2. Now once again, I want this to equal 0, because that's where maximums are found. So I need to factorise. I can take out 30x, and that will leave me with 4 minus x. Quickly double check that, is that right? Looks good. Okay, so this has two solutions. Either this is 0, which means that x is 0, or this is 0, which means x is equal to 4. Now let's look at the diagram and sense check which one could be possible. Can x be 0? Well, no, because x is the radius, so it wouldn't be much of a shape if it had no radius. So x must be 4 then. Okay, great. And a lot of people think, woohoo, I've solved the question, 6 marks in the bag. But in fact, they asked for the maximum value of y and not of x. So we need to substitute this back into the formula for y in order to actually solve the question. So y is equal to 60, open brackets, 4 squared, minus 10, 4 cubed. Okay, so we can go to our calculator to do that. So 60 times 4 squared minus 10 times 4 cubed. 320. Beautiful. Love that question. It's almost like an A-level question. Yeah, come on. Okay, right. Another tough question here. Another really tough question. It says that the point A is the only stationary point on the curve with equation y is equal to k x squared plus 16 over x, where k is a constant. Given that the coordinates of A are 2/3 A, find the value of A. Okay, right, first step is to write this out in a way we can differentiate it. So I'm going to write that as 16, and then the 1 over x is the same as x to the minus 1. Now the clue that I'm going to need to differentiate this is the words stationary point. Those are the maximums or minimums, and they occur when the gradient function dy by dx is equal to 0. Okay. Okay, so given that the coordinates of A, right, okay, so got it. So we can differentiate this, and this gives me 2 comes down, times by the coefficient, which is k, to give me 2k, x, power drops down, so it's just x to the 1. Power comes down, times by 16, to give you minus 16, x, and we drop the power down, so minus 2. Okay, now as we know that at the point where x is equal to 2 over 3 is our stationary point, it means at that point dy by dx is equal to 0. So I can say that 0 for dy by dx is equal to 2k when x is 2 over 3 minus 16 2 over 3 to the minus 2. Okay, great. So this gives me 0, and it gives me 4 over 3k. And then what is this? This looks horrendous, but we can solve that by just going into our calculator. So 16 times 2 over 3 to the negative 2, and we get 36. Lovely. Okay, so rearranging, we get 36 is equal to 4 over 3k. Then just divide that by 4 over 3. And we get k is equal to 27. Okay, and then you think, yes, I've done the question. Oh, actually, they're asking me to find a. So I need another bit of information. Well, the other bit of information is that this actual point must be on the curve, because it's where the stationary point is, so it's on the curve, which means it should satisfy the equation of the curve, which means I can substitute it into this equation. Okay, so the y is a, we have k, which we know is 27, x squared, and the x coordinate at this particular point is 2 over 3, plus 16 over 2 over 3. Okay, I probably should do this in my head, shouldn't I? Look, on the bottom here is a 3, and that's going to be squared, so that makes a 9. So then we're dividing 27 by 9, which gives you 3. Then we're timesing it by 2 squared, which is 4, so that gives you 12. Now when we do 16 divided by 2/3, it's the same as timesing by 3 over 2. So 16 times 3 is 48, and then divided by 2 is 24. So therefore we have a is equal to 36. Bosh. Okay, back again. Oh, another tricky one. We've got a rectangle and an equilateral triangle. Okay, so that means that that's x, and that's x, and that's x. The perimeter of A, B, C, E, D, so the whole shape is 100, and the area of the whole shape is R. Okay, show that R is equal to blah, 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 blah. Oh. Okay, no, fine, fair enough. Okay, yeah, this is just a GCSE paper. No, it's not fair, fine, yeah, okay. Right, let's start with the perimeter then. So the perimeter is 100, and we know that's equal to, oh yes, right, I see, because the area is going to be in terms of y. We're going to have to use y to find the area. But actually the area formula here has no y's in at all. So we're going to have to use the perimeter formula to find y in terms of x, and then we can substitute it into our area formula to eliminate y. Okay, so perimeter is equal to 100, and just going around the shape, you can see that's x, y, plus x and x, plus another y over here. Okay, so that's equal to 3x plus 2y. So that means that 100 minus 3x is equal to 2y, which means that 50 minus 3 over 2x is equal to y. Okay, great. So now we need to find the area of this shape. I think is this the trickiest topic? Maybe I've misnumbered them, and maybe this one should be number 60. I don't know. Okay. So what we're going to do? Well, in order to find the area of the rectangle, that's relatively straightforward. That's just x times y. The area of the equilateral triangle is a bit trickier, because what we need to do is we need to split it up into two right angle triangles, like so. And we know that this side will be x over 2, and we know this angle here will be 60, because it's an equilateral triangle, so they have angles of 60. So we can find the height, h, by using our good old friend trigonometry. So I'm going to avoid using x over 2 because that's got a fraction in it. I'm going to use the opposite and the hypotenuse. So I'll write sine of 60 is equal to the opposite. So opposite the 60-degree angle is the height, which is what I'm looking for because I need it for the area, over the hypotenuse, which is x. Okay, great. So the height, multiplying both sides by x, is x sine 60. And you can find sine 60 on your calculator, but I know that it is root 3 over 2. So it's root 3 over 2x, because sine 60 equals root 3 over 2. Again, just you use your calculator for that. You don't need to know the exact values for sine in the Edexcel IGCSE. So we have the height of this triangle. Great. In fact, I didn't need to write that at all, because all we could do now is just do plus a half base of the equilateral triangle, which is x, times by the height, which is root 3 over 2x. Okay, lovely. Right. Let's get some more space. Okay. So we say r is equal to x. We have an expression for y. It's 50 minus 3 over 2x. That came from our perimeter expression. Plus a half x. Let's multiply this out now, actually. So we have a half times by a half here. So that gives me a quarter. And a root 3 on top. So root 3 over 4. And we've got an x times an x, so x squared. Okay, let's expand this out as well. So 50x minus 3 over 2x squared plus root 3 over 4x squared. Okay, let's take out a factor of a quarter and x, because I can see that they've taken out a quarter x, so we need to do the same. So by taking out a quarter x, I'm going to times everything in the bracket by 4 and remove an x as well. So that will give me 200. Okay, and then timesing by 4 gives me minus 6, and I have to take an x out as well, so it's just minus 6x. And timesing this by 4 gives me root 3, and again I have to take an x out, so it's just x. Okay, so I think we're nearly done. So this gives me 200 and then we need to do minus. We need to take a minus out. What is this question? Honestly. So that'll be 6, and that'll be minus root 3, because a minus and a minus will make the plus here. And then we can put the x on the outside as well. And we have it. Yes, we do. Wow, it's insane. 3 marks! Oh my gosh. Okay, right, let's go on to part B. So it says find the value of x for which r is a maximum value. Okay, so I'm just going to do it up here because I want to keep this working here. So the maximum value happens when we differentiate. Now, in order to differentiate, I need to actually expand these brackets. So I'm going to do that. So I'm going to expand the first term here. That's going to give me 50x. Now, when I expand the next one, I'm not going to do it in full. I'm just going to write minus, in brackets, 6 minus root 3 will be divided by 4 because of the 4 outside the bracket. And the x times the x will give me x squared. Okay, so that's now a form that I can differentiate that. So I get dr by dx is equal to 50, because 50x differentiates just to 50. Now x squared, we times the coefficient by 2. So timesing this by 2 is just going to change the denominator to over 2 rather than over 4. And then the power drops down like that. And when we're maximum, we want that to equal 0. Okay. So what I can do next is I can move the this term here to the other side, and it'll become a positive. Like so. I can then times both sides by 2, which gives me this. And then I can divide through by this 6 root 3. So I get x is equal to 100 over 6 minus root 3. Explain why the maximum value of r is given by this value of x. Well, if we go back up here, we will see that the r expression is a negative quadratic, because the x squared term is negative. Now, negative quadratics have an n shape to them. So it's r is a negative quadratic. So the graph has an n shape, and this type of graph has one maximum and no minimum. What a question! Oh my gosh. Okay, question 22. The diagram shows a sketch of part of the curve with this equation where p is a positive constant. For all values of p, the curve has exactly one turning point, and this turning point is a minimum shown as the point t in the sketch. For the curve where the x-coordinate is, of t is minus 3, find the value of p. Okay, so this is another case where we're going to have to differentiate. So what I'm going to do is write it out as y is equal to x squared and then minus p, and then the x is x to the minus 1 because it's on the bottom. So it's minus p x to the minus 1. Okay, let's differentiate that. We get 2x, and then with the minus 1 comes down with the minus there to make plus. px to the minus 2. Okay, and we know that's there's a turning point, so that means the gradient equals 0, and that happens when the x-coordinate is minus 3. So we need to, so I can say that at x equals minus 3, the gradient function equals 0. So sub in minus 3 into this expression and we should get 0. So 2 times minus 3 plus p minus 3 to the minus 2 equals 0. Okay, so that's minus 6. Minus 3 to the minus 2 is 1 over 9. That equals 0. So that means p over 9 is equal to 6 by moving the 6 to the other side. So therefore p is equal to 9 times by 6, which is 54. Perfect. Okay, next question. The line with the equation y is equal to k is a tangent to the curve with this equation. Find the value of k. Okay, well, if we have a tangent and its y is equal to k is equal to k is a straight line. So any curve which at the point where it's tangent must be a turning point. So once again, we can take this function and we can write it in a form that's differentiable, and then we can differentiate it. And we can get 2x, and that will be plus 16x to the minus 2. And we can set that equal to 0, and we can find this corresponding, we can find the x-coordinate of this point. Okay, so the x-coordinate, well, let's write it now because we're trying to solve this. We can write this as 16 over x squared equals 0. Because negative 2 power is the same as writing it as on the bottom of a fraction. We can then multiply every term by x squared. So that gives me 2x cubed. That will cancel the x squared there, and that will still be 0. We can then divide every term by 2. We can move the 8 over, and then we can cube root, and the cube root of minus 8 is minus 2. So this x-coordinate is minus 2. But what we want is we want the y-coordinate, because that will tell us exactly the line, which is the y equals line. So to find the y-coordinate, we need to substitute back into the y equation. So y is equal to minus 2 squared minus 16 over minus 2. Minus 2 squared is 4. The two minuses here will cancel out to make a plus, and 16 over 2 is 8. So that means it's equal to 12. So that means this coordinate is minus 2, 12. So the line which cuts across must be y equals 12, because it goes through the y coordinate of 12. Bosh, so k is 12. Okay, last question. The curve has this equation, yeah, and the point A with coordinates that lie on C. Okay, brilliant. And the gradient of the curve at A is 16. Great. Okay. I'm going to use those two bits of information because I can see at the moment I've got two unknowns in my equation for y. So I'm going to need two bits of information. Well, that is too large a highlighter. I'm going to need two bits of information in order to find A and B. So that's my first port of call, and I'm going to sub in 2 minus 6 into the y equation, the equation of the curve, because that point is on the curve, so it satisfies the equation. So we have minus 6 for y is equal to a 2 cubed plus b 2 squared minus 12 times 2 plus 6. So this is minus 6 is equal to 8a plus 4b minus 24 plus 6 is minus 18. Add the 18 to both sides, gives me 12 is equal to 8a plus 4b. Divide the whole equation by 4 just to simplify it, and we get this. Brilliant. Obviously we can't solve that yet, we need another bit of information, but that is all good. Okay, so now let's look at the blue bit of information. The gradient at the curve at A is 16. So to find the gradient, we need to find the gradient function, which is dy by dx. When I differentiate, the power comes down, becomes the coefficient, or times is by the coefficient. So 3a, and then drop the power down by 1. So the next one will be 2b, drop the power down by 1, is x to the 1. And then this one is a 1 power here, so times by minus 12 is minus 12. Drop the power down, x to the 0 is 1, so we don't need to write it. And any constant differentiates to 0. So that is it. The 6 differentiates to 0, and we are good. Now what it says is that at the point A, so that's where x is equal to 2, dy by dx is equal to 16, the gradient. So we can say 16 is equal to 3a when I sub in 2 for x, and then plus 2b, again sub in 2 for x, minus 12. So 16 is equal to 2 squared is 4 times 3 is 12, so 12a. 2 times 2 is 4, so 4b, minus 12. Add the 12 to that side, gives me 28, like so. Divide the whole equation by 4, gives me 7, 3a plus b. Brilliant. So 2 equations have been found, so let's solve them simultaneously. I've got this one and I've got this one. Let's write them side by side, one on top of the other. Let's put the bigger one on top and the smaller one on bottom. Subtract to cancel the b's. So this gives me 4 is equal to 1a. Sub back into one of the equations. Let's go with the bottom one. 3 is equal to 2 times a is 4 plus b. 3 is equal to 8 plus b. So b is equal to minus 5. Perfect. Now, what's the question actually asking? Find the y-coordinate of the point on the curve whose x-coordinate is 3. Okay, great. So just sub in x is 3 into the equation, which we now know fully, and that will give us the y value. Okay, let's just move this out of the way. I'll just delete it, in fact, so that I can now have some space and I can see the full equation. Probably should have deleted that. That was quite important because a is 4. Let's delete this instead. Okay, a is 4, so our equation is y is equal to 4x cubed plus b is minus 5, so minus 5x squared minus 12x plus 6. And now we are subbing in x is 3. So y is equal to 4, 3 cubed minus 5, 3 squared minus 12 times 3 plus 6. So 27 times 4 is 108. 9 times 5 is 45. 12 times 3 is 36, and then plus 6. So that gives me minus 30, minus 75. Take 75 away from that, gives me 33. Beautiful. Job done. Wow! It's like A-level style questions, this. If you like this topic, then you're going to love A-level maths. Right, bye for now.